Good afternoon, everyone. Yeah. So, in the previous lecture, we have discussed the how to define constraint using the schema, and we have seen the basic form of implementing certain constraints. Okay. Someone's mic is unmuted by mistake, and we have seen the basic form of defining elements, attributes in schema, and we had also seen how to define the rules like if the user is not providing the data, then how to take the default values or fixed values using a schema definition. Now we'll continue to explore more XML schema definition, in which we'll see more features of it, like providing the custom types or creating or extending the existing data type or restricting existing data type. So these are the advanced feature of the schema definitions, which are frequently used in our XML schema definition. So we'll explore this today. Let me share my screen. And we'll quickly go through what we already seen. Yeah. Hello. There is some issue with the browser. It is not responding, but am I audible? Okay. So we'll quickly recap few things. We have understood what is complex type. So can anyone say which elements are uh, said to be complex type in XML schema? Which elements are said to be complex type? Correct. The elements which contains children elements, or one more thing, or it may contain attributes, right? So an element will be said to be Hello. Here internet connection is unstable. Okay, so let me share my screen. Yeah, so we are discussing about complex type. So the element which contains sub-element or it may contain attribute or both are called complex type. Otherwise, it is called simple element. So simple element contains only text. It cannot contain any other element or attribute. So there are element can be classified as either complex or simple. Based on that, we need to define the elements accordingly in using XML schema. So to define the simple element, you can simply specify the element keyword, the name of the element, and the data types. So we have seen the examples of those these simple elements like last name, age, date born, and how to define them in XML schema file are like this. You provide the name of the element and data types like string, integer, date, and the elements can be defined easily in the schema. So it is very simple to declare the simple element in as per the XML schema definitions. We had also seen to provide the default values or fixed values. So simply use the keywords default or fixed. These are the attributes that you assign to the element. That attribute's default value is some string or it has some fixed value. So simply use these attribute names default and fix. So they are easy to remember because the attributes names are default and fixed. So that we can easily remember it. Then how to define the attributes itself? Now the attribute itself is simple because there are no sub element, there is no such concept of sub element or text of attribute. Only attribute can contain only values. So using attribute keyword or attribute element name, you can define the attribute, provide the attributes like name and type to define the attribute name and its data type. The example is say suppose I have an element last name with the attribute name language. This language can be any language. So to define this attribute, use the keyword attribute. Name is equal to language and type equal to string. Okay. So this is how we define the attribute itself. Like element, the attribute can also take on the default values or fixed values so that we can define them using the default and fixed attribute names. So again, it is quite easy to define the default values of the attribute or fixed values. Now remember, attributes are optional by default. So if you are trying to define the attribute, it is not necessary the user has to define the attribute for that element. If you want to make that attribute mandatory, you can use the keyword use equal to required. So for any element, it can take on one or more attributes, but even though we have defined the attributes, by default they are assumed to be optional. And that's why if you want to make one or more attribute as the mandatory, then you can define that attribute with the keyword use equal to required. So for optional, you need not do anything. You can simply ignore this value like use equal to required. By default, it will be optional. Now, like I told you, that XML schema has features of restricting the content of available data type. For example, if we have a string data type, then string will allow any text. But if you want to restrict it to, if I want to restrict it to certain values only, then we can do so using the feature called restriction on the available content. And technically they call it as a facets, but we'll remember it as a restrictions. Suppose I want to define an element car with values available or only allowable values only Audi, Golf or BMW. Then in that case, we can define an element car. Now it contains only text. That's why it is a simple element. So that's why we define it as a simple type. And within that, we need to define the restriction, because by default, if we define the data type of the car as a string, then all allowable strings will be there. But if I want to allow only few of the values like Audi, Golf or BMW, then I can use the enumeration. So list of enumeration or list of values for the enumerations are these three strings, right? And they are restricting from the allowable data type. So base data type is string. So we know in any inheritance we are extending, but here we are doing the opposite of it. Instead of extending the data type, we are restricting the values of the data type. So car is a the car element is of simple type, and we are using restriction because I don't want to allow all the any string possible, but out of the string only three possible values are Audi, Golf and BMW. So we are using the enumeration. So I hope that this example is clear. Okay. I think we have. Did we see this or not? I don't remember. White space. Okay. Yeah. So I will explain this. So in our XML, as the data, we can have any text value which may contain white spaces like spaces, tab, new line in terms of carriage return or line feed character. So, so there are different ways to deal with the white spaces. By default, suppose I want to preserve the white spaces. That means the processor or the XML processor might remove the extra white spaces and it will replace it with a single white space. Then I don't want to do it. So I want to preserve whatever it is there. I want to keep it as it is. In HTML, we very well know that in HTML file, extra white spaces are trimmed by the browser. Okay, so browser will take on the HTML file, and if the tag contains extra white spaces like paragraph, div or anything, then it will remove the extra white spaces. So we can explicitly tell to the XML processor that don't remove the white spaces, keep it as it is, and that's why there is a special keyword white space and with the value equal to preserve. So it will not touch upon any white spaces. So see that we are using an address, and address may contains address is contains only text, so it is of simple type, and new restriction is on the base type string. We want to make sure that the string contains white spaces and the all the white spaces are preserved as it is. Any number of white spaces, no processing will be done on the white spaces. On the contrary to it, if we want to replace multiple consecutive white spaces, with single space, then or with spaces, then we can use this replace. So whether the it is line feed character, tabs, space character, carriage return character, all these are called as white spaces. They will be replaced by the space character. So depending upon our application, we can tell to the XML processor to whether to preserve or replace. And one more is there, collapse, in which multiple white spaces are truncated to a single space. So if there are multiple white spaces, multiple consecutive white spaces in my paragraph or in my address, then all of them will be removed and replaced by a single space. So there are three things: preserve, replace, and collapse. Okay, so we have preserve, replace, and collapse. So depending upon the requirement, we can use these values. Now this example is on the data type string, but suppose I want to restrict the integer value. I want to put the constraints on the available integer value or numbers. Then we can use this keyword min inclusive and max inclusive. So suppose I have an element age, and age contains some numbers. So basically it's a simple type. I want to restrict, instead of specifying the data type integer, I want to restrict it to the values between 0 and 120. So we have to use restriction, and we have to use additionally this constant min inclusive and max inclusive. So minimum value 0 and maximum value 120. So that means if I have age something like 20, then this is fine. But if the user is providing something like this, then XML processor will invalidate the file, and it will pinpoint that the age is not within the range, provided range. Or even if you provide negative numbers, that will not be allowed. So basically it is checking against the allowable range of values. Similarly, it supports the pattern. Through the pattern, you can provide the regular expression for the possible values. For example, here for the element password, we want to restrict that the password must contain only alphabets and numbers, and the length of the password must be 8. So this is how we specify the regular expression. Here, the keyword that we need to use is pattern. So these are the different restrictions on the numbers, or on the strings we can use pattern. I hope that you must have encountered many regular expression, and you can easily get this notation. Whatever is specified as part of between the square bracket is allowed, and within the braces we are specifying 8. That means those numbers, those characters can be of maximum 8, or rather not maximum but 8 times. Yes, Rikin is asking 0 and 120 is allowed. Yes, because it is inclusive. See the term, it includes the values 0 and 120. If it is not allowed, then it should have been exclusive, but here we are using min inclusive and max inclusive. So we have to see there is a list of constraints that we can provide. There is a, I think here, yeah. So here see that there are also max exclusive and max min exclusive. Yeah. So, okay, let's go back to the example. So this is the password, must be 8 character, and it cannot contain any other character other than alphabets and numbers. And then you can provide more regular expression, like here What is the possible value of later? Correct. It will allow only small alphabets. Can it be empty? Can we have something like this later without any text inside it? Yes, it is allowed because it is asterisk means zero or more occurrence of the alphabets A to Z, all the small alphabets. So for the second example here, the letter can contain any text containing only alphabets, small a combination of small and uppercase, and plus that means it is one or more. So at least one character is required. It cannot be empty. Then we can use the pipe character to define the optional values like gender. We are specifying the string is either male or female. So pipe character between these two values. So that can also be used as the pattern. And there is one more like length, which can be operated on the string data type, that the string length can is 8. So the length of the password must be 8 character. So these are the, yeah, additionally we have more constraint like minimum length and maximum length. So your password can be of minimum length of 5 character and maximum 8 characters. So again, all these are example of different kinds of restriction that you put on the base data type. Yeah, and this is the table of all the possible constraints that you can put on the different data types. Okay, so now we'll discuss the simple type and complex type. We already discussed it. If the element contains only text, it is called simple. Otherwise, it is called complex. That means it may contain a sub element or child element or attribute or both. Okay. Now you remember this hierarchy of the element type. So there are two types of elements in XML schema, either simple or complex, that we already seen. But now we'll see that this complex type is further classified as either containing simple content or complex content. I hope that the first one is clear. Element can be either simple type or complex type. There is no doubt in that. Okay. Now we'll discuss about this complex type is further classified into two types: containing simple content or containing complex content. So in both the cases, an element can contain attributes, but if the element contains sub-element or child elements, then it is said to be having complex content. But if it doesn't contain child elements, then it is said to be having simple content. Is the distinction clear between simple content and complex content? Now we are further classifying complex type. The only difference is very simple. If the complex element contains child as the elements, then it is called complex content. Otherwise, it is called simple content. So, what are the possible elements that an element can have in complex type? Sometimes it is empty. Sometimes it may contain only sub-element. Third type of complex elements are containing text with some attributes, and sometimes it is combination of both. It may contain text as well as some elements. And always it is possible because if you see this classification, that complex element can always contain attributes. So in both of these content, either simple content or complex content, attributes are allowed. So remember this, attributes are allowed in complex content. So we'll look at the example how to define the elements of different complex type. First one is empty. So this is an example of empty element which contains an attribute product with the product ID. Second example is an employee which contains other elements as the children. So first name and last names are the child elements of the employee. Third example in which it contains only text. So food is an element with value ice cream and the data type, the attribute type equal to say desert. So it contains only text. And the fourth one is an element which contains both the text as well as element. So it's a combination or mixture of the text and element. So fourth one is somewhat different. You might not have encountered it, but this is possible that your element may contain combination of text as well as other elements and even multiple elements. But the only thing is it must follow the convention like start tag must be ended with the end tag. So they must be valid element. Okay, so we cannot miss the closing tag or we cannot miss the opening tag. So this is completely valid and this is allowed as the complex type. And now we will see how to define the definition in the our XSD file using the XML schema standard. I hope that these examples are clear enough. If not, you can immediately post your question in the chat box. Okay. Now, suppose we'll go with the example wherein employee. Okay. Here in this example, employee contains two sub elements, first name and last name. So I want to define this in our XML schema file. So first of all, we use the element with the name employee. It is complex type. And because it contains element, that's why it is complex content. Fourth type is restriction because now the data type for my child is derived from the base type any, but I want to restrict it to a certain values only. So we use sequence. So there are two sub elements, first name and last name of data type string in that order only. So this is how employee should be defined in our schema file. I hope that this you are getting it. First is simple element with the name employee. It is complex type because it contains element. Third line is complex content because it contains elements. That's why it is not simple content. So complex type are always either simple content or complex content. Right now they are complex content. And then there is a restriction because I don't want to allow any data type, but I want to allow only the first name and last name as the child elements. And I have highlighted these few lines like complex content and restriction. I will tell you the reason why I have done it. Yeah, it is see that in XML schema definition, It is not compulsory, but if you don't write, it will assume it to be the complex content. And let's see the next slide. This is an abbreviated form. You can remove these two lines, complex content and restriction, and corresponding closing tag as well. So if I remove these two lines, complex content and restriction, from my XML schema, the resulting declaration would be something like this, and it is a valid form. And most of the time you will see this notation. You will not encounter this type of definition in schema or anywhere, because by default it automatically assume it to be the complex content. So that's why for brevity purpose we remove those lines, and normally you will encounter this type of definition. But remember, internally it is assumed like this. Okay, processor assume like this, because earlier if you look at the example, yeah, so see that we are specifying simple type and then restriction here. But here you have to you need not write this explicitly in this example. You can just remove those line, and this is also parts correctly, and it would be validated without any issue. So normally we will write something like this. We can ignore the complex content and restriction. Okay. Now we have this is one more feature of the schema, XML schema definition standard, that it allows you to create the custom type. So suppose I have an employee, and within that which contains complex type with two elements, first name and last name. So basically what we are doing, we are declaring these two elements, first name and last name, or we are declaring this complex type local to the employee, because it is declared inside employee element. So you know the concept of local and global scope. Okay, so here you can think of this complex type, the scope of this complex type, as the local one, because it is declared inside the employee element. But if I want to declare it globally, I can remove this definition from inside to the employee element, and I can put it outside, and I can give it a name. Something you already know in C language, there is a feature called type def. I hope that all of you remember that type def feature. Using that, you can create your custom types, like you can create nodes or structure or linked list, okay, data structure or tree node and so forth. So here also what I have done, I have just removed that complex type and declared it outside the employee element, so it will become global definition. And now I need to provide the name. The name provided to the complex type is person info. This can be used as the type for the element employee. So there are two ways to declare the same thing. One is like this, that employee contains two elements, first name, last name, because and then they are complex type, or employee has the type person info, where person info is declared to be complex type with two sub elements, first name and last name. Both are valid form. You can use either one, depend as per your preference. You can use either one. But later on, for the complex file, if you find something which is repeated multiple time, uh, this defining type would be much more better. It will reduce the total file size. It will also increase the readability of our schema file. To the XML processor, there is no harm whichever version or whichever form you use. Is it clear? I think you can easily relate it with the existing features you know about different languages. And then not only for one, you can use it for different elements. Like I have an element with employee, student, member. All of them has the type person info. That means all of them can contain first name and last name. So now basically it will reduce the file size and it will also increase the readability, and the data type can be reused again and again. So your employee, student, and member, all of them are having type to be person info, and person info is defined to be the complex type containing two elements, first name, last name, using in that particular sequence only. Now another feature of the XSD is inheritance. So if you are using inheritance in other programming languages, we are adding properties or methods to the existing data type. And similarly, if you have some custom type, we can add it to few more elements or attributes to the existing type using the feature called extension. So let us see this example person info. We already declared person info is a complex type with two sub element, first name, last name, which in particular sequence. And now we are defining another complex type which is called full person info. Again, it is complex content, but now we are extending the base type person info, and I want to add address, city, and country to that base type. So person info defines only first name and last name, and full person info will add few more elements like address, city, and country. And now for the element employee, we can define the type to be full person info instead of simply person info. So see that because we are using extension, we must provide the complex content as well as the element extension with the base type person info. So it is similar to we are extending from some base class and we are having the derived class which will add few more properties or methods to the existing class. So here instead of class we are having the type complex type, we are adding more elements to the existing type by the use of extension feature. I hope that this example is clear. Okay, fine. Let's move on to the next complex element, which is empty. So simply define the element name product with complex type, and it contains an attribute product ID, and the data type is positive integer. So this is how we declare a complex type which is empty element. That means it doesn't contain any text or sub element. And if you want to define a complex element without any attribute, then simply define the element and specify the complex type. But now as part of the complex type, there are no attributes, neither attributes nor elements. So that's why complex type is empty. So this is my empty element. Okay. Custom type we already seen that Yeah. So earlier we have defined the custom type for element. Similarly, you can define the custom type for the attribute as well. So I have the I'm defining the complex type with the name product type, which contains only one attribute called product ID with the data type string. Now it can be used as the type for my element product. Okay. So here you can see that now the element product will contain the attribute product ID. So any element where I want to assign the attribute product ID, I can simply define the type to be the product type. So it can be reused again at many places in my XML file, or rather XSD file. Yeah. So this example we already seen that an element contains only child element. So an element person will contain uh, first name, last name in that sequence, and it is complex type. And we also seen how to rewrite it using the custom type. So we are creating person type, and we are using the as the type of that element person. So this is already we have seen. Now, sometime the complex element will contain only text. In that case, we can use either extension or restriction. Okay. So in that case, we have to use simple content because it contains only text. So let us see the example. Suppose I have an element shoe size with the value 35. So shoe size is simple type. It is not it is simple content, not the complex content, because it doesn't contain child elements. Okay, it doesn't contain any children. So shoe size, we are defining element to be shoe size, which is complex type, but now with the simple content. Now I want to define, I want to either use the extension or restriction. So here we are using extension with the base data type integer, because now my valid values of the shoe size is number. So I am using integer. Even you can use positive integer because negative numbers are not allowed. And it contains an attribute called country, which is having data type string. So this is how you can define the complex element which contains only text. So see that here the terminology used, if you find or if you search, when they say text only, it doesn't mean only text, because complex elements can always contain attribute. Okay. So remember this thing, even though the they will be calling it as a complex text only elements. Remember, it is implicitly always understood that complex element can always have attributes. And it is up to you whether you want to make it mandatory or not. By default, attributes are optional, right? So I hope that this example is clear. And you need to remember the simple content and complex content. I think it is easy enough, because now we have seen many example. If the element contains children, then it will be called as a complex content. Otherwise, it will be called simple content. Same definition rewritten using types. Okay, so I am skipping this slide because now this inside of that local declaration of the complex type has been removed, and we declare it globally. That means outside the element declaration, and then we are defining the type. We are giving the name which is used as the type for some element. Now the fourth example of the complex type was mixed content. So look at this example. There is an element letter which contains some text, which is a mixture of text and elements. So it is meant for some person. The name of the person is informed about order ID placed by him, and also informing the shipping date for that particular order. So this is also a valid element, and it is called complex because a letter contains sub element. But now you will see that it is mixture of both. So combination of text and element. That's why it is called mixed content. Though it is a complex type, but the element contains mixture of text and elements. So how to write this? We need to define the element with the name letter. The type is complex type, but with the attribute mixed equal to true. So this is how we define the complex type which contains mixed values. So it will contain the element name, order ID, and ship date. And it is a mix. We are writing mixed equal to true, and that's why the element later can contain mixture of both the text or combination of text and elements. Same example rewritten using the types. Okay. Instead of the local type, we are creating global type, giving the name and then reusing it as the type for my later element. Okay. Now we have seen the use of sequence. So you might ask that everywhere we are using sequence, but what if I don't want to make if what if the user can add this element in any order, then we cannot use sequence. Okay, if the order is not important, then we cannot use this sequence. Basically it is called indicator, order indicator. So in that case there are two more indicators, all and choice. Okay, so let us see all indicator. So suppose I am defining an element person, which is complex type. Instead of sequence, we can use all. So here the order is immaterial. You can define this first name and last name in any order. Okay, so for that you have to use the all indicator. Okay, instead of sequence, you have to use all. I hope that this example is clear. So far we have seen the use of only sequence, but now you can use all if the sequence is immaterial. Okay. Here, instead of sequence, we are writing all. That means this first name and last name in my XML file can appear in any order. Maybe first name after last name or last name after first name. In any order. Both are valid. But if I use sequence instead of all, then within person element, the first name should appear first and then only the last name can appear. So the order matters. The next one is choice. In the choice, only one of the elements can appear. So suppose here person can have either employee element or member element. So I have list of elements, only one of them can be there. Okay, and that's why the name given is choice, which is more more appropriate name for the indicator. So there is only one choice, either employee or member. If there are say 10 elements, out of 10 element, only one can appear, not all of them can appear. Now this occurrence indicator. So you can use the indicator like max occurs or mean occurs. Okay, let me have So here you can see that suppose here this element first name. Can you say how many times first name can occur within person? How many times first name can occur? Are you getting my question or not? Yeah. So this is my XML data. So yeah, only one time. The reason why, because there are two occurrence indicator. One is mean occur and another is max occurs. There are two indicators, mean occurs and max occurs. By default, their values are 1. So both of them are having value 1. And that's why this first name can appear only once or last name can appear only once. But if you want to change it, suppose I want to make an element appear more than one time, then I can use the different values for mean and max occurs. So here you can additionally specify this mean occurs equal to 0 and max occurs equal to 5. That means first name can occur 0 or 0 up to 5 times. 0 times 1 times, 2, 3, 4 or 5 times. So I hope that you are getting this mean occurs and max occurs. You can assign it to any element. By default, they are there and with default values of 1. And that's why always we have assumed it to be 1. But there is some rule for if you are using the all indicator, the values of mean occurs and max occurs can be 0 and 1 only. Okay, so minimum mean occurs can be 0 and max occurs can be 1, or both can be 0 or both can be 1. We cannot have higher values. And suppose I want to for other elements like for other indicators like sequence and for others choice, this value can be anything. It is user defined. And if you want to make it infinite, there is a unbound. You can have the value of max occur to be unbound. So here suppose for child name the max occur equal to 5. That means this child name element can occurs maximum 5 times, and the default value of mean occurs is 1. That's why minimum 1 time and maximum 5 times. So these two indicators are used to define the cardinality. Basically, it defines number of times an element can occur in my XML file. Yeah, so you can change these values, mean occurs, max occurs, according to your need. Okay, fine. At this point, we will stop and I will upload these slides into the Google Classroom and you can refer to it. See that in any case, the default values of mean occurs and max occurs are 1. 1. It is 1. It is always 1. Mean occurs and max occurs. The only thing is if it is used inside all, it cannot take on any other value other than 0 or 1. Okay, Janil is asking if we write 2 times, what will happen if max is 1? So it is not allowed. Na? See that mean occurs should be less than max occurs. Less or equal. It cannot exceed the value of max occurs. So it should throw an error basically. XML processor should throw an error. Yes, you can ask the question, Kanal.
Sir, what happened if for same XML if we write XSD and D2D?
No,
Then how?
no. See that if you are writing when we declare the root element, at that point we specify whether we are using the schema or we are using the DTD. We cannot specify both. Either of only this can be specified. If you are using external DTD, we can specify the external DTD. It is not allowed that you can use both the things. No, either you use DTD or XSD, not both. Okay, we'll stop at this point.
Sir, which one is preferable, XSD or D2D?
Definitely XSD. We have studied the schema DTD just for begin introduction purpose only, because it is easy to learn. So for as a beginner, we can know the DTD, but nowadays only XSDs are used because they have more features than the DTDs. Okay, fine. Thank you.